Okay, great. I hope you can see. All right, so we continue our discussion from where we left off. I can't even remember when we had our last class, but hey, so I tagged this lecture series as fundamentals of software engineering. Oh, sorry, managing and organizing a software development project. But it turns out that the first couple of slides for the lecture series actually centered around process activities associated with the software development life cycle. So the things that you probably find yourself doing, right? There we go. And so it's likely that this thing is going to be split up into different, well, into two separate lecture series, right? So this is all. Right. So a couple of announcements, guys. So there's an assignment, right, that's associated with this lecture. It's called Project Team Composition Sign Up. So the task is very simple. All you do is and today is one of those messy days, right? Oh shit, it's gone. It's fine, I'll find it hopefully. So the first task that you're going to have to do is sign up for project team, right? Remember this conversation last time? We said people are supposed to choose a team that they wish to be a part of, right? So you log into the Moodle, that's a simple task. Oh, this is messed up. You log into the Moodle, and then, today is one of those funny days. You log into the Moodle, and then you will have to sign up. So we've changed things slightly. It's going to be 4 to 5 people per project. We want to cut down on the amount of time we're going to have to spend assessing the homework, right? Evaluating, marking the assessments. Right. So like I said, there's a restriction on it's like a POR anyway, and the restriction is the group composition cannot exceed 5, right? So it's between 4 and 5 people, and the deadline is the 10th March, so you better sign up for a project team as soon as possible before Friday next week. Right, and then at some point next week, a list of project topics will be circulated. Well, not circulated, but they'll be made available on the Moodle, again as homework. Your task is going to be, as part of the group, 4 or 5 of you will decide on which topic you want to work on. I would encourage each and every member to be a part of the selection process because you're going to be part of this the entire year, right? This is going to be next week. Hopefully that should give you time between now and next week to find people you want to work with and then decide. Okay, so this is what I was talking about. So you find a restriction, that's the restriction. What you do is when you go onto the Moodle, you find the project sign up link. It's part of, it's going to be part of lecture 2, which is this one. So you notice they're actually explicitly labeled, the lecture series, right? And all you have to do is so if the people you're going to be working with are part of project team number 1, what you do is you just click this, say become a member, and then that's it, right? That's all you want. So 4 to 5 people. I don't think we can have 0 or 1 person, no. So if you're one of those people who doesn't speak to other human beings, you learn how to do this now because you have to speak to people to work with, right? Okay, and then also I have pointers on the project selection thing. I'm saying if you're struggling to find individuals that you could potentially work with, what you want to do is you can use the mailing list, right? And just broadcast a message and tell everybody, I want to be a part of a group, I've been left out. You should do that, serious, I'm being honest here. And the idea behind that is you want to start interacting with people. Also, you can make use of the forum in the Moodle, right? Okay, so like I said, the lecture series, unless if there are any questions, no? But yes.
So what's the basic criteria of selecting a group? The group that you want to be.
I don't know. You are in third year. You know people by now.
You talk to them.
Sorry.
You talk to them like let's create a group.
Yeah, you talk to the situation here. I don't understand. How else are you going to? You have to speak to people. You see, if I had interacted with you last year, I would have, because sometimes this self-organizing groups can be a bit of an issue. I don't know what your strengths are like insofar as what you did last year is concerned, so it's a bit difficult for me to dictate to say, you know, the four of you form one group, right? So, and I know what's going to happen. Probably some groups are going to be way better than others because people will select, you know, but I don't know. Okay, but if you have challenges, again, do let me know, right? Send me mail and tell me. So I have a problem finding a person. If you are shy to send an email and tell people that you are unable to do that. If there are no questions, then I'll proceed, right? Okay, so the layout is going to be as follows. And I thought we'd start off with a discussion. It's in parts, right? Because these are sort of like disjointed, they're not related in any way. So I thought we'd start off with a more in-depth discussion of the software development lifecycle. So essentially the different processes that are involved insofar as software development is concerned. And then afterwards we'll dive into what we are calling project management fundamentals. So and really when we discuss aspects of project management in this course, we are going to cherry pick what we think are important things associated with software development, right? So we'll touch on things like scheduling, you know, how you break down logical activities associated with a project into smaller units that you can work on. What else is there? So breakdown structures, project scheduling. So how you assign tasks to individuals, right? So we'll look at the fancy things like, I think they call them RACI charts or something, right? And I have a very interesting story about project management. I was working from out of town and we were working on this project. Project we've been working for more than a year now. The thing with the, no offense to NSU, but the thing with the person who was managing the project is there was no explicit planning. And so what ended up happening is you had a situation where some people were doing more work than others, some people were doing less work, right? And some people had no idea what it is they had to work on, right? So we ended up wasting a bit of time here to try and harmonize the different aspects of the project, right? What I'm trying to say here is it doesn't really matter whether you're working on a software development project or, oh, hi. Yes, hi, sir.
From security.
Yes.
Closing at 17. So
yes, I know. The class goes up to 17. Thank you very much. Thank you for letting us know. Oh, well, you're not, is there food in here? Now this is what I was saying, guys. I knew the confusion was still there, right? Normally this place doesn't close until I think somewhere around 22 or something. I thought it was faculty staff politely trying to drag me out, say, what are you doing here? Okay, so, but the bottom line is it turns out that it doesn't really matter what you're working on. When it comes to project management, you can apply these things to different facets of life, right? It doesn't have to be software engineering. And then I thought it would be nice at some stage for us to look at what I'm calling case examples. So these are somewhat like projects that I was a part of or projects that I executed myself to showcase to you how the planning process is done, right? And I decided to include, I think there's two fourth-year projects, well, one fourth-year project and honors project, which are both a year long, similar to the duration of your capstone project next year, and pretty much similar to the duration of the project this year. And then there's a project that I worked on that was almost 4 or 5 years, so to look at how you go about planning, right? And the importance of planning, really. So just examples to give you an idea of what you're supposed to be doing when you start working on this mini project. And then I thought finally in part 4, we're going to look at some tools, some software tools that you're likely going to use for you to come up with some of these things that you have to do insofar as project management is concerned. So how do you come up with, I guess, a visualization of the project schedule, for instance, right? We'll look at Gantt charts. How do you break down the different high-level activities or components of the project into smaller manageable chunks? So we'll look at how to create a work breakdown structure. And there's a disclaimer once we start discussing tooling where I mentioned to say we're third year now. I'm not saying that you should use the tools that I'm going to introduce you to in here. It turns out that there are plenty of tools, right? I don't know what IDE PL used or you were using last year. What IDE for Java? Yeah, so, but you've discovered that there's more besides Dr. Java, right? That's what I'm saying. Okay, so what we're going to do in part one really is just looking at the different software process models. And again, here we're just introducing the, first we're just going to introduce the, I guess the logical phases associated with a typical software development project. And then we'll also gloss over some software process models that exist out there, right? It turns out that the different approaches that you end up adopting depending on the nature of the project, the timeline within which you have to execute the project, the requirements coming in from the eventual end users, right? The owners of the project. And then we'll look at some, the actual logical structures, the process activities themselves. All right. So typically, the so-called software process is split up into activities that you have to execute as you're undertaking the project, right? And it turns out that there are a number of processes, right? And they're split up into these core different categories, right? So you start off by coming up with what they call a software specification, where you go through a process of trying to identify what the specific requirements of the thing you're building are, right? So if you're building, let's say, a student information system at UNZA, what you do is you go through a process where you talk to the people that are going to use the student information system to collect the requirements. You don't necessarily have to talk to the students, but perhaps you might have to talk to the lecturers, right? The people in administration, right? I don't know if security is involved with any sort of malpractice associated here, so you have to speak to them so that you know exactly what you need to build as you're building the software. And then you go through a design and implementation. It turns out, by the way, that the software specification phase is perhaps one of the most important things, right? Because if it turns out that you build something that people are not going to want to use, you'd have to redo the process. Which is why it's important to get your requirements right from the onset. And then you go through a design and implementation process where you identify the logical components or modules associated with the system, and then you write the actual executable code associated with whatever it is you're building, right? So this is where you have your programming, right? The design, I guess, incorporates things that were introduced to us last year, like pseudocode, right? As you're writing the actual code to generate the executable, the software. And then obviously, because remember you collected the requirements, you need a way of validating or verifying that what you're building actually works and fits into what the end users actually want. Right, so you test, it turns out there are a number of testing phases that you go through, right? And we'll look at all those different things. And then the evolution part really is, it turns out that sometimes you go through, it's not like once you're done with the last step, then that's it. You go through a loop, right? Irrespective of the type of software process model that you're using, you tend to go through a loop where the evolution would incorporate things to do with operation and maintenance. It might just turn out that a year down the line, the user will come back to you to say, certain things have changed at UNZA and we want changes made to the student information system, right? So operation and maintenance. It might require that you implement an additional module, right, or a feature. Or it could be that maybe these people have, I'm trying to think here. Like the grade point, the GPA was not there in the past, right? Previously, it was just A plus, D plus C, right? But after the introduction of the GPA, the software had to be changed, right? I don't know if that would qualify as a feature, perhaps just a modification on an already existing feature, I don't know. It doesn't matter. The bottom line is that this is tied to evolution, right? Operation and maintenance. And really, you notice that this software process is nothing more than an abstract representation of general process, right? These things here we're talking about, you are abstracting the gory details that are associated with each of these different categories, right? There's a lot more involved. So you realize just now that the design process involves things like database design, architectural design, right? The implementation might require you coming up with modules and software components, right? Integration with existing third-party tools and services like APIs, right? Web services, right? So it's just an abstract representation of the process itself. Just a reminder that when we're talking about this so-called process, what we are doing is discussing the activities that are associated with the software process, which are these things here. And this will come out a lot once we start looking at the different software models, because in as much as the activities are performed in different ways, it turns out that all these things are incorporated in the different software models, the activities. Right? And so it involves things like specifying the data models when it comes to database design, designing of the user interface, which would be, well, I guess, well, design is design, right? And then coming up with an explicit order of how you're going to perform these activities depending on the software process model that you're utilizing, right? But obviously the process description itself might also include things like the end products of the project, right? So it might not be software alone, but documentation, manuals, right? Once you develop that software, you want to give people instructions on how to use the software, right? As a programmer, as a developer, you probably have intricate details of how the software works, and so you might think people don't need a manual, but they definitely do need manuals, right? Otherwise, you have people calling, how do I do this, right? And then things like roles, right, responsibilities that different people associated with the project are going to have to perform. Perhaps you would need a dedicated resource who is part of the project who is going to handle the design. Somebody else who's going to, well, architectural design, somebody else who's going to look at the database design, right, the data model itself. Somebody else who's going to look at the user interface design. Or if you want, you could decide to say all the different team members are going to work on the different activities associated with the project. Usually works well if you're working in a much smaller group to have everybody involved in the process. But in a real world setting, what you have is different people performing different roles, right? So you will not have the same person come up with or do the programming and then collect the requirements. So you have a dedicated resource or dedicated resources or individuals that go out there to collect the requirements, and then individuals that are going to concentrate on the programming, perhaps individuals that are going to concentrate on testing, right? I have a colleague of mine who worked for years as quality assurance engineer or something, and his role was just to test software components that people were developing. I think he was working for, I don't know if it's UNICEF, one of these NGOs, right? So for some of these dedicated roles, like having a dedicated resource to go and collect the requirements, normally work quite well when you're working on large and complex software, right? Not a small little project like the one we're doing, but an example I can think of right now, the people working on Facebook, obviously it's become so complex, right? So it's obviously people that are dedicated to collecting requirements that have to feed into modifications that could potentially be made onto Facebook, right? And typically, like, you might also have things associated with post and preconditions associated with what you're developing, right? And usually you specify these things once you come up with artifacts such as use cases, right? Or use case diagrams, or use case descriptions. All right, so it turns out that there are certain software process models that require that you come up with a plan of what you're going to do beforehand, and these are normally referred to as plan-driven processes, right? So before you do anything, you come up with an end-to-end plan of what you're going to do by when, right? And who is going to do the different activities associated with the project. But compare this, contrast this with agile processes where you quickly come up with implementations, or feature sets associated with your software, right? And expose it to the user gives you feedback, and then you make alterations. So you go through a cycle where you quickly or rapidly come up with an implementation, expose it to the user for testing. If the user is happy, then you move on to the next feature set, right? If they're not happy, you make changes to what you are implementing, which is why it's called an agile process. So the planning process is essentially incremental. You go through a loop. Well, you go through a loop even in plan-driven processes. The only distinction is that in a plan-driven process, you perform all the different activities, you finish the project, and then you go back in a loop, right? But it turns out that, I guess, in most instances, you have it's rarely the case that you take a plan-driven approach. You choose either to take a plan-driven approach or an agile-driven approach. It might just be the case that you combine the two together. So you come up with this plan of how you're going to execute the project, and then some aspects of the project are probably going to take advantage of agile processes. And just to mention here that there's nothing like this is the best process, although increasingly these days you notice that if you look up literature online, most people tend to gravitate more towards agile process. The so-called traditional software development processes rarely used these days. So the waterfall model, for instance, is a classic example of a plan-driven approach. But bottom line is there's nothing like the plan-driven approach is better than the agile process. It depends on what you're building, requirements coming in from the users. So sometimes people come up to you and say, this is what we want, but if you could if within 2 months, if you can give us the software with this feature set fully functional, we'll be happy, right? So what you do is you focus more on building or implementing that feature set, and then after you deliver that functional feature of the application, you continue on with the remaining features. So these are the different categories associated with the different software process models, right? So there's the traditional model, also referred to as the waterfall model, and you see why it's called the waterfall model. You have to perform each task at predefined phases in the project, right? So there's nothing like you do implementation before you gather requirements. You must gather all the requirements, then you do the design, then you implement, then you go through operation and maintenance, and then you go through a loop. Right? Incremental development processes like Scrum, for instance, will take advantage of rapid prototyping where you quickly build the features, like I say, right? And then it turns out that increasingly these days, because most of the functionalities associated with the software what we build is pretty much common, right? These days, if you're building a web application, you almost always have a login module, right? Authentication and authorization module. You don't have to build that thing from scratch. You can just go out there and pull something that fits the requirements of the user, which is where this process comes in, so integration and configuration. And normally what happens here is you rarely develop these components or features from scratch, but rather you pull existing components. They're available. You remember ICT 1110, I introduced this, when we're looking at types of software, we introduced this notion of, is it libraries and, yeah? These would fall under the category of libraries, although we are loosely defining libraries here, right? Depending on the type of, I guess, programming language that you might be using, or tools you might be using, these things that you're assembling together, right? They come in different shapes and forms, modules, libraries, packages, right? It's one and the same thing. Right, and of course, I mean, you could decide to take, in as much as you're following an integration and configuration process model, but you could decide to say you're going to take a plan-driven approach and agile approach, right? Don't, when we're working on our projects, let's not assume that going out there and lifting code that has already been written fits into the integration and configuration module. No, that's cheating, right? No, that's true. Like lifting an already existing software and you pass it around as, oh, we use the, integration and configuration process model, right? So No, and we'll design, the problems actually are scoped in such a way that you won't be able to do this. Anyway, but again, right, like I said, if you're working on complex software, I remember when I was a student, there was this new lecturer who was attached with the Ministry of Finance. There was a lot of money pumped into a system called, there was a project called the IFMIS project. If you ask people that work in the Ministry of Finance, most of them will tell you to say it was a failure, it was a failed project. Don't know how much of that project they're still using up to now, like the software that they generated afterwards, but it was a failed project. And we'll probably touch on, I guess this is why it's important to plan, and we'll look at ways of avoiding project failures, right? The last thing you want is for the mini project to fail. But remember again, when you're working complex software, you're involving all these different parts of the project. Because you have to realize this, right? If you're working on like if you look at Facebook, let's use something that most of us can relate to. You realize that when you look at Facebook, there's that news feed. I'm guessing they have a friend feature where you add people, you block people or something, you unfollow people, right? It might just turn out that the different groups working on those different portions of the project might decide to take or to use these different software process models, right? One of them could just decide to say, we're going to take an approach where we exclusively use a plan-driven model, or we'll take advantage of agile processes, right? If you look at the bigger software here, this thing we're calling Facebook, you realize that it incorporates all these different things here. I'm trying to think of a component in Facebook that takes advantage of integration and configuration here, and I can't, for the life of me, I'll be surprised. It's probably there, but I'll think of an example, and then I'll probably mention it tomorrow when we meet or something, right? Ooh. Okay. All right, so in terms of the waterfall model, you remember I introduced this notion of ensuring that an activity is performed before you move to the next, right? This is why it's called a waterfall model. The fact that you must, first of all, perform requirements, elicitation and analysis before you come up with a software design. You cannot start implementing before you design the software completely. You come up with a complete design of the software, right? You implement, and then of course unit testing is like Piela told us, when you write these small little programs, you have to test, right? These unit tests have nothing to do with the user. It's just like you testing that the programs that you've written actually work, right? Equivalence tests, right? So if you're working with if you're working on a piece of software that is involved with grading of students, part of the unit test would be to ensure that the module that involves computing the grade of a user is alive to the fact that there is no negative grade and the grade cannot exceed 100. But you can't say, I'm sure this works. You have to test it, right? And I know Pierre introduced us to the different tests that we perform, right? You test the boundaries, you test the middle components, right? Just because the grade is a range from 0 to 100 doesn't necessarily mean that you have to test all the different things. Right? I'm trying to introduce this notion of looking at the boundaries, the external boundaries, and then look at the things that fall within those different categories or classes. So lower bound for D and upper bound for D, lower bound for D plus, upper bound for D plus, lower bound for A plus, upper bound for A plus. And then if you're content with the fact that if your test passed, then you know that your unit test was obviously successful, right? Otherwise, you fix it. The last thing you want is to actually deploy this with such an error, right? In certain instances, it actually costs a lot of money. Think of software that is developed for the financial sector, banks, for instance, right? You make a mistake and there's no limit. The feature that allows a user to specify a withdrawal limit is simply not there. Their card is stolen and, you know, well, just speculating here, someone draws all the money in there, right? But I'm just saying, unit testing, right? And then finally, after you implement and you perform unit tests, you go through integration and system testing, and we'll look at this in depth, right? So remember, you have these different modules or components associated with the software. At some stage, you're going to have to combine them into one. you must test that you must test the system as a whole to confirm that when those different things are combined together, they work successfully, right? And this is going to come up for you guys because I have a sneaking suspicion that we are probably going to, when it comes to the implementation part, you will likely split up different components of this software you're going to be building. And so at some stage, you would have to integrate the different components and test the system as a whole. Does it work as a whole? Does it fail to work after you combine the different things, right? There's a process that you have to follow for you to perform integration and system testing. Integration because you're combining the different components. System because you're testing the entire thing as a whole, so the entire software as a whole. And then this is the evolution, so operation and maintenance, right? It's tagged evolution because it's a continuous process, continuously. There's a reason why Windows has updates, operation and maintenance. There's a reason why they'll say we have version 5.1 of the software, please download it or something. There's a reason why your Android operating system normally prompts you, tells you to say there's an update, operation and maintenance, right? Anyway, right, so fundamentally, these are the core processes that we just spoke about here. The problem, though, is that it's difficult if you get to a stage where you are implementing. It's difficult for you to incorporate new requirements into the process. You'd have to first of all finish what you're doing here, go through the entire process, and go to the beginning, right? Right. So you have to complete the previous phase before you proceed to the next one. Right, so this is what I was talking about customer requirements, right? If the new requirements that are introduced, breaking it up into distinct stages becomes a difficult thing to do here. Yeah, so these days, right, I'll be surprised if, in fact, maybe this statement actually, I don't know if this statement is accurate. It's not always the case that large systems are the ones that make use of this traditional software development model. But for the most part, when you're working on complex software, that's when you tend to work on, that's when you tend to use this software process model, the waterfall model, right? It's perfect for large and complex software. If you are contracted by, I don't know if there's a new bank comes to you and say, we want, these days it's become common, let's use an example of a domain we understand. You'll be shocked once you go for teaching practice that very few schools have records management systems. They still use that paper-based system, right? I dare you to go to the school you were at, maybe not now, but once you graduate, go there after 5 years and ask them to say, I want my record from when I was at this school, my entire record, right? Do you have it? I doubt they'll be able to give it to you, right? What was I saying here? Oh my God, I don't know, I lost my train of thought here, but I wanted to link that example to what I was trying to say here. Large and complex software, right? So a school comes to you and say, we want an electronic records management system. I think I have Alzheimer's disease or something. You'd have to use the waterfall model because you need to properly plan for that. It's going to be complex. It's not easy, right? It's not easy. You have to take into account that there are specific rules you have to follow as far as records management is concerned. Come up with decisions on when you're going to delete those records, right? A policy, right? Do you delete the records after 5 years or something? Or do you archive them somewhere or something? Right, so that's like, I guess, some hypothetical example that would be perfect, or that would be linked to a waterfall model, right? It's a large project. So think large projects, large and complex projects. Listen, I'm rushing for a class here. I was late, and they're going to close this. But I'm going to leave us at the waterfall model. Tomorrow at 11, we'll continue our discussion of these different process models. I think we should be able to finish. The. What are we calling this? We should be able to finish the our discussion of this tomorrow. Software development lifecycle, right? And then we'll immediately transition into project management fundamentals. So one of the reasons, right, you will notice certain things that I've done here. Ideally, we probably should have started with the project management part and then we move on to the software development lifecycle. But I've decided to fuse in certain things here because it turns out that for you to properly come up with a plan of these mini projects, you need to understand the end-to-end process, which is why I'm introducing these things right now. Right, so when you're reading up, also I do encourage you to read some of your book, right? In fact, most of the content in the slides are based on that book. Is that fine? So tomorrow we will continue, guys. I'll see you when you see me. Hey, I know it's being recorded, but I don't know if are we still at a stage where we complain about resources online, right? About resources and books. No, right? We know, right? We know how to find those things. Google LibGen, right? LibGen. LIBGEN. Now, I'm not encouraging this, but there's a story I'll tell you tomorrow about this. Remind me if I forget. But thank you.